first we're going to go over descriptive statistics and central tendency and dispersion. A lot of these terms might be familiar to you, but we're just going to go over them just so we all have a base understanding of them. And then we'll go over what significance levels are. All right. Central tendency. So mean, median, mode. So mean is just the average of all data. Median is like the number in the middle of a data set. So let's say you have 7. Let's say you have 5 data points. The third data point would be in the middle of the 5. That would be the median. And then mode is just the one that appears the most. So if you have like 10, 10, 10, and then 13, and then 15, well, 10 appeared 3 times. So 10 would be the mode, and then you forget about 13 and 15. So let's do a little quiz. Can anybody tell me what the mean for this data set is? 0, 0, 20, 20. Yes, that's perfect. Yeah, this is going to be 10. Does anybody know what the median for this is? 0, 0, 5, 29,000. Yep, that is 5, because it's in the middle of these 5 data sets. What is the mode here? 0, 0, 11.9, 99, 999, 3,999, and then you guys 0? Yep, that's perfect. Because 0 appears twice, and then although there's a bunch of 9s, these aren't data points, right? There's just 9s. The only 2 same data points that we get is 0 and 0. We have that twice. Everything else we have once. 0 is going to be a mode. So it's important to know these because when you look at a graph, sometimes things get skewed. So this is a normal distribution where you have even numbers of data points all over the place. Positively skewed just pretty much means that you have everything around this area, and then you'll have 0, 0, 0, 5, 5, 5, and then over here you might have 30, right? And there's just that one outlier, and then that skews everything off to the side, which is why, can anybody tell me why just going off the mean is not always the best idea, especially if we get a positive skew or a negative skew? So we have all of these, let's say everybody's around this area, right? And then there's just one person all the way over here. This is probably where we want to target, right? Let's say you're trying to sell something and you 100 people spend 20 seconds looking at your website. And then there's just one person over here who spends 10 hours, they left their computer on or something. Now that mean is going to be way over here, and you're going to assume people spend a minute on your website when it's only really just 20 seconds. So in that scenario, why would the mean be a bad thing, going off the mean? Right, perfect, because the outliers can just completely destroy the mean, and then you kind of get away from that mode. So that's why median is nice. Mode is interesting, because honestly, you could just have a couple people I don't know, over on the sides, and the mode might not even be here. Generally, the mode's here, but you might not be here. So I personally like median. Do you have a preference? I know you can't say one is better than the other. I generally like median.
Median's good. I mean, it's best when you can get all 3.
Yeah, for sure.
But I do think mode is the weirdest because it can just get throw you off. But between median and mean, you have a pretty good idea of I don't know, where you should be expecting things to be.
Yeah.
If you're able to see the difference between the two, you can tell.
For sure, yeah. Okay, so now that's kind of just it's a joke. So this is just skew if you want to think about it on a test. Skew you, and then behave normally. So this is normal, skew, and then you just want to remember that if you see this on a test, if you see a weird kind of line like this, skew to one side, and then normal curve, and we'll go over normal curves a little bit later, but and just to be clear, no curve is ever really like this. You're always going to have some probably level of skew. Now we're going to go on to dispersion, which isn't how the center. It's not talking about the center. It's talking about the range of ideas, which is one of the terms. So first term, range, total covered by lowest to greatest data point. If you want to figure out the range, you could subtract the highest number from the lowest number. And so, but you want to do the absolute value. So let's say you're 8, and there's -2 over here. Absolute. You don't want to do absolute value. You want at the very end you do an absolute value. So 8, and then you do minus -2, which would be 10, and then your range would be 10. Standard deviation is the amount of difference from the mean. So you have a central line like we showed before, and then on average, how far is a singular data point from the mean? So let's go over some examples. What is the range of a data set where there's a 2, 3, and an 8? 6. Yes, 6, because we can take the highest and lowest, subtract the highest, or we subtract the lowest from the highest. 8 minus 2, 6. What is the standard deviation of -1, -1, 1, and 1? First, before we answer that, let's go over the mean. What's the mean here? Yes, it's 0. So the mean we have is 0. Now, on average, how far away are each of these data points from 0? Right, so the standard deviation in this case would be 1. So when you think of standard deviation, it's like you got to do a little bit of extra work. It's like you first got to figure out what the mean is, and then you got to calculate how far away. And there's a lot of formulas you can go through. I would recommend just going to Google Sheets and just standard deviation equals standard deviation. But, yep, perfect. And so going back to the standard deviation in a normal curve, if it's skewed, it's going to be different. But in a normal curve, the majority of your data points are going to be within 1 standard deviation. This is weird mark right here, simple, it's just standard deviation. So it's going to be within 1 standard deviation. And then as you get into the extreme areas, you're going to see diminishing returns. 2 to 3, not as much. 1 to 2, not as much. Majority should be within 1 standard deviation.